Hi Calculus 1 students. In 2.3 limit laws, we encountered this limit. The limit as t is approaching 0 of sine of t over t is equal to 1. And the point of this video is to make the proof of that. Okay? We will do it, first of all, I call this the fundamental trigonometric limit, okay? It's my own name. It's not the name, it's not an official name, but it's just that we understand each other, in other words. The proof is in 2 steps. The first thing we're going to do is we're going to prove it from above. We're going to prove that the limit as t is approaching 0 from above of sine of t over t is equal to 1. Once this is established, we will prove that the limit from below has to be equal the limit from above. 1 and 2 together, of course, will prove that the two-sided limit is also equal to 1. Okay, now before we begin, I want to stress out that what's most important is not to remember the details of the proof, but it is to remember the intuition, why this is true, okay? So the way to see it is, let's say we have a circle of radius 1. So in other words, the unit circle. In this case, the angle t is also turns out to also be the arc length of this circle. Okay, so it has a value of t as well. And the height of that point is sine of t. Okay, so what this limit is telling is that as t is approaching 0, so in other words, as the angle is getting smaller and smaller, as the radius is closing in, as the angle is closing in the x-axis, then the height and the arc length are getting closer and closer to each other. Okay, so you can imagine that for an angle very, very small, like this would be the height, for instance, the height and the arc length are almost indistinguishable. So they're approximately equal to each other. And this approximation gets better as the angle is closing into 0. And another way of saying that these sine of t and t get approximately equal is to say that their ratio is approximately 1. Okay, so this is a way to understand this limit. Now for the full proof, the idea is to create 3 areas, have an inequality between them, and use the squeeze theorem. Here's how we proceed. The first area will be this triangle. Okay, and this green side right here will be cosine of t. Okay, so this is the smallest area. So area of inside triangle. The second area will be the sector. So in other words, this we know has a value of 1. Okay, so this, because it's the same length as the radius, okay? And this defines a sector of arc length t. So is the area of sector. And finally, we will draw a big triangle. Okay, so we will take this side to be perpendicular, and we will extend the radius like this, okay? So, okay, we know that this is t. And if we do this, then this length over here is also 1, which makes this to have value tangent of t. Because for a given angle t, the tangent of t is opposite over adjacent. So since we know that the adjacent is 1, we know that the opposite is tangent of t. So we will call this the area of outside triangle. Okay, now very reasonably, there's an inequality between these areas because the regions are contained in each other. So we start with this inequality. The second thing to do is obviously to create expressions for all of these areas. So for triangles, for example, we have base times height divided by 2. Okay. The sector is the hardest to kind of wrap our head around to. It relies on the fact that we know what is the area of a full circle. That is pi r squared. Okay? So the fraction of the whole circle that this sector takes is t over 2 pi, which would be like the full angle, the full revolution, right? So this is fraction of circle, okay, multiplied by pi 1 squared, which is the area of the full circle. So area of full circle. Okay, so we got that. And now the area of the outside triangle, so we get it in exactly the same way, base times height, so tangent of t times 1 divided by 2. Okay. Now, we're going to do two things to this inequality. Okay, so the first thing we're going to do is we're going to multiply every side by 2, which is not going to change the inequality. So multiply by 2. But one thing we will also do is to divide everything by sine of t. Since it's a positive number, it doesn't change the inequalities. Okay, so divide by sine of t. Okay, so sine of t is positive, so doesn't change the inequalities. Okay. Now, how do I know that the sign is positive? Of course, is because of this. Okay, so remember here that we are doing step number 1. We are assuming here that the angle is above the x-axis. Okay, so if we do that, so it means that we're getting rid of all the 2's at the bottom, and it means that we're dividing everything by sine of t. So what we get here is cosine of t. Then here we have cancellations, the pi, and we have here t, so that's it, t over sine of t. And finally, here, the 2's cancel out, and tangent over sine, as you know, is going to be the cosine. It's going to be 1 over the cosine. So actually, let's work this out a little bit more thoroughly. So sine of t divided by cosine of t, so that's the tangent. But since we divide that by sine of t, so 1 over sine of t, okay, it ends up being, so this thing right here ends up being 1 over the cosine of t, okay? So now that I work this out, I will erase this and just put 1 over cosine of t right here. And we are almost done, the step number 1, okay? So now I will erase t, I will erase this. So now the next step is to use a decreasing function, and that function is 1 over x. Okay, so since 1 over x is a decreasing function, so if x1 is smaller than x2, and actually I have to be careful, it's a decreasing function for positive numbers. So positive numbers. We have that if x1 is greater than x2, it means that 1 over x1 is smaller than 1 over x2. Okay? So as a result, what happens when we flip every side of this inequality? So we have 1 over cosine of t, and instead of t over sine of t, we have sine of t over t, and we have here the cosine of t. Actually, as I can see, we don't really need to do this, but oh yeah, we need it in order to have this in the middle. Okay, so what's important is that instead of being smaller or equal than, it becomes greater or equal than because of this fact over here. Okay, so here I'm just gonna put here inequalities are switched. Get swapped. Okay, now we're taking the limit of all of this as x is approaching 0. So it means now that we have three limits. The limit as t is approaching 0 plus of 1 over cosine of t. And I will stop color coding the inequalities, which is bigger or equal than the limit as t is approaching 0 plus of sine of t over t, which is bigger or equal than the limit as t is approaching 0 plus of cosine of t. Okay, now I'm erasing this. However, these limits are not indeterminate forms. They're easy to compute. So this is 1 over cosine of 0, so it is 1. Greater or equal than the limit as t is approaching 0 plus of sine of t over t, which is bigger or equal than, again, this limit is easily seen to be 1. So by the squeeze theorem, we have that this limit is 1. Okay, so limit as t is approaching 0 plus of sine of t over t is equal to 1. Okay, so here I'm just going to specify that is the end of step 1. But we are not finished, because the only thing we did is that we proved it for positive values of t. Now we have to prove for negative values of t. So we have to do step number 2. Okay? So now I will erase this. So I'll just put a check mark over here, like this is done. Oh, and I should mention here that it's by the squeeze theorem. Well, I said it, but, well, okay. Okay, so step number 2. Okay. So this step doesn't have any squeeze theorem or special kind of algebra. What we will do is a change of variable. Okay, so we would like to compute the limit as t is approaching 0 from below of sine of t over t. Okay, so the first thing we're going to do is a change of variable. So we will say if u is equal to, so we're going to call it a variable u. If u is equal to negative t, then as t is approaching 0 minus, u is approaching 0 plus, okay? Because u is the opposite of t, okay? So, for example, if t is 1, u is negative 1. So if t is approaching 0 from above, u is approaching, well, if t is approaching 0 from below, then u is approaching 0 from above. So, which means that this will turn into the limit as u is approaching 0 from above of sine of, and now be very careful, we're going to replace every occurrence of t by negative u. Okay, so we haven't done any magic here. What we said is that if u is the opposite of t, so in other words, we can replace t with negative u, then u is approaching 0 from the other direction. That's the only thing we said. Okay, now here's the tricky part. So for here, we're using the identity, which is very, very sensible. Sine of negative an angle is negative the sine of the angle. So in other words, and this comes from the fact really that, so we have x and y, or actually, I will not even tell where it comes from. Like, if you have any questions, of course, you can ask me. But we're using this identity in order to turn the top. So we still have u is approaching 0 plus. But now the top becomes negative sine of u. And the bottom stays negative u. Now, obviously, as we simplify things out, as we simplify the negative signs, we get the limit as u is approaching 0 plus of sine of u over u. Okay, so let's actually copy this down. Okay. Now, I will just say that this u over here is called, well, I will call it a dummy variable. What I mean by that is that once we perform the limit, we don't have u's or t's anymore. Like as soon as u is approaching a certain value, it disappears from the expression. So writing that the limit of sine of u over u as u is approaching 0 plus is the same thing as writing the limit of sine of t over t as t is approaching 0 plus. So we can actually replace now here every occurrence of u's by t's. And here we go. This is the end of step number 2. There you go. This is the end of the proof. So just to recap what we have done, we proved that the limit from above is 1. And then we proved that the limit from below is equal the limit from above. So in other words, the limit from below is also 1, making the overall limit 1. That's it. See you in the next video or in the next class.